Section 2.9 is all about operations with complex numbers. So our goals for the day, or actually, sorry, I'm getting ahead of myself, our warm-up, just asking how to add terms together and how do you think we might add other terms together. So the first one, how do you think, or how do we add the term 6x plus 3 plus 4x plus 8? Well, we're going to add the like pieces. So the 6x and the 4x give us 10x. And then the 3 plus the 8, those are like terms, that gives us 11. So it ends up being 10x plus 11. Now for the other one, we have 6 plus 3i plus 4 plus 2i. So using like the same or pretty similar numbers there, we're going to add the like terms. The 6 and the 4 we can add together, we get 10 again. Now we can also add imaginary terms together. So the 3i plus 2i is going to give us plus 5i. We're going to rehash this in just a little bit. Pardon me. So our goals for the day, we're asked to do the following with complex numbers. We're going to graph them. We're going to calculate the absolute value. We're going to add. We're going to subtract. We're going to multiply. We're going to simplify, aka divide. So let's get going. So to graph a complex number, what we're going to do is we're going to come up with a new axis. We're going to have an x-axis, that's going to be the real number axis. And then the y-axis is going to be our imaginary number axis. So say, for example, we're graphing the number, let's do 2 plus I. So if I'm graphing 2 plus I, I'm going to go 2 over on the real axis and then positive 1 up on the imaginary axis. This is 2 plus I. On the next page, we're going to practice a couple other ones. So for letter A, it says 2 minus 3i. So we're going to go 2 to the right and then down 3. And that's point A. Then we're going to do negative 1 plus 4i. So we're going to go 1 to the left and 4 up. And so that's point B. Letter C, 4 plus I, go 4 to the left, 1 up for the positive I, so that's letter C. And then negative I, there's no real value there, so we're just going to go down 1 to negative I, and that's letter D. The absolute value of a complex number is all about the distance. Just like distance away from 0 is like an absolute value of a number, we're going to be talking about the absolute value as of a complex number as the distance from the 0 or the origin. So the absolute value of a complex number, a plus bi, is the distance from the origin to the point AB. So we're kind of forming just like a normal point in a coordinate plane, and we're going to take the absolute value of it. Now let me zoom in on this image here a second. So if we have the coordinate 3 plus 4i, it's kind of like we have an a value, we have a b value, and we have a c value here. It's a good old right triangle. So a plus bi, the absolute value of it, that's like our c value. That's the distance from the origin, is equal to the square root of a squared plus b squared. You might have noticed I accidentally put a c squared there because, well, really we're taking c squared equals a squared plus b squared and taking the square root of both sides. So the distance that we're looking for on that hypotenuse of that triangle is the distance formula. It's a squared plus b squared, but we're taking the whole square root of it. So for this exam, or these examples here, we're asked to find the absolute value of 3 plus 5i. So the absolute value is going to be the square root of 3 squared, and I'm going to put that in parentheses, plus 5 squared in parentheses. 3 squared is 9, 5 squared is 25, so we have the square root of 34. There are not a whole lot of factors to 34. You got like 1 and 34, 2 and 17, and that's about it. So we're going to say that is the distance. That is the absolute value. Now for letter B, you'll notice there's no a value. So our a value is 0 squared plus negative 7 squared. So we have 0 squared, which is 0, plus negative 7 squared, so plus 49. That just gives us the square root of 49, which is 7. Now if you think about that one especially, if you graph negative 7i, you would just go 7 down in the y-axis. So 1, 2, 3, 4, 5, 6, 7. And that would be your point there. So how far away is that from the origin? Well, that's 7 away. So that's our absolute value.